Math Genius. I am Lanisha, the owner operator of Bud and Bear Fruit. By day, I'm a district math coach. By night, I am trying to get these kids to be successful in their math classrooms. And I am joined by Dana Harris and Akil Parker. Could you please introduce yourself to the people?
Well, I go by the name of Mr. Dana W. Harris. I am the Chief Academic Officer of Young Gurus Math Tutoring, an online tutoring platform. I am a father first, and yeah, I educate the youth by day. My day job is I'm a Math 2 teacher in high school. For those of y'all that aren't in the state of North Carolina, that's pretty much equivalent to Algebra 2.
And I am Akil Parker, founder of All This Math, a platform, a company where we offer math tutoring and also a YouTube channel where we have a goal of improving the relationship between math and the Black community generally. And I'm also a father, father of three. And yeah, I just enjoy teaching math and learning math, especially with these two people, learning math from them. And I'm also an adjunct math professor at Cheney University at the same time.
I love to hear
Dr.
it.
Parker.
Yeah.
All right. So tonight we have an interesting conversation. Kids are getting ready to go back to school if they're not in school already. So I want us to tap into ways that we can empower these parents to support these kids using some of the things that we are training our teachers to do in the classroom. So our math myth buster for tonight is I can just tell you and you should be able to get it. Okay. I know everybody can relate to this meme here on the side with the lips balled up and Johnny and Jimmy and all them apples. Okay. So I don't want parents to feel this way. I don't want parents to feel this way. How y'all feel about this quote, this myth right here? How y'all feel about it?
First, let me say, when I read that, I think about the video where they had the Black mother up there going on. So, but no, on the learning side, on the teaching and learning side, what comes to mind is the fact that we got to think about the different learning styles, right? There's some people you can just tell them how to do something and they can process it fast. But those same people that you can do that, they might get certain things fast and other things they might, take a little longer to understand it and to get it. And sometimes kids don't fully understand what questions to ask, right? And then if it's a parent that's maybe not the best math teacher or math person, flag on the play. I'll just keep it at teacher. If it's a parent that's not the best math teacher, then that can be a struggle. And so when I look at this, the things that come to mind is you got to think about the different learning modalities, right? Some kids, we can show them how to work out the problem. We can create a picture about Johnny and his apples, and then we can show them an equation. And then now we've no longer made it just verbal. So it's not just auditory learning going on, but now it's possibly kinesthetic learning going on too. If you actually get some apples or some objects that are apples. But I think that's the main thing to encourage parents to realize that there are different modalities of learning: visual, auditory, kinesthetic. And for those of you that aren't familiar with those terms, visual is just like it says, they can see things and they can get it pretty swiftly. The auditory, they can hear things and it processes well with them. And then you got the kinesthetic. Those are the kids that they need to touch. It's not an apple, but they need to touch things to count them and things like that. And so when you start connecting into those different modalities of learning, now the possibility of understanding and retention is increased.
Yeah, I say one of the things, and I'm trying to, I guess, speak from experience because I've had those moments, where I used to yell at my oldest son, especially, and not as frequently with my daughter, but I kind of was growing out of it, and hopefully with my baby, my youngest son, hopefully I'd never yell at him in these types of situations. But I think that what's necessary is for parents to have a growth mindset and to think like, because a lot of times as parents, we learn how to do certain mathematical calculations and processes, and we learn only one way though. So we're like, all right, this the only way I know how to do it. So if you're gonna get it, you got to learn it this way. And then we feel like, disheartened if, if my child doesn't understand it after I'm trying to explain it this one way, then we think like, it's like the world is caving in. But that just means we have to go learn other ways, or we have to think more deeply even about that one way that we might know. So that way we can like kind of break it down even more. And I think also for parents, I want to suggest this is get away from this idea that um, your child's ability to understand it in that one way is a valid measure of your child's intelligence. Because like Dana was saying, like with the multiple intelligences, like just because if you don't get it and I show it to you this way, that don't mean you dumb. And I think a lot of times like parents may have a fear that like, oh snap, like, maybe my child not that smart. Um, but that's only because you're presenting it only in this one way. That might not be the best way for them to get it. And it doesn't mean that there's anything necessarily wrong with your child, you know. And the last thing I would say about this is because you like look at the brother's face, like the brother's clearly angry. This meme always makes me laugh. But that's how some of the parents are, right? And what we got to realize too, and I always, again, I have my own experiences, like, getting frustrated with my own children, but it's like illogical to get frustrated with them because most people, um, when that emotion kicks in, the cognitive ability gets shut down anyway. So it's like, it almost once you start yelling and whatnot, it's like, even me sometimes, like if I'm in a tense situation and it's a lot going on, like even like as a teacher, like if I'm in a classroom and I've been in classrooms where it's a lot going on and people aren't paying attention over here, somebody not paying attention over there, somebody's being disrespectful, and I got to address them, and then I can't teach the best that I can teach because I got it's a lot of others, it's too much going on, right? So I can't really focus. My ad libs don't come out, my metaphors don't just pop in my head like while I'm doing my explanations. So so as a parent in that that personal situation, personal more intimate setting with your own child, when you get the yelling and the cussing and all that, like it's because your child, you're kind of, you might have, like I mentioned earlier, a fear that your child might not be as smart as you think they are. And even if you don't explicitly say that, your child is interpreting that, they're receiving that from you. So then they thinking like, damn, maybe I'm not that smart. So then it might be something real basic, like 3 times 9. Your child might know 3 times 9 is 27. But if it's like, well, I don't feel like I'm that smart. So I think it's 27, but I might be wrong because now I'm starting to question my own intelligence because I'm getting yelled at. So now you thinking like, well, I think it's 27, but actually, no, it's not 27. Maybe it's 25, you know? So again, like with the yelling and everything, it blocks the cognitive ability. So we gotta, as parents, we gotta check ourselves and try to stay calm and as best as possible. It's not gonna be easy, but we gotta do it though.
Right. I'm glad you brought up your personal experience, because I usually do that. Like I'll say I only have one child, so it's not like I learn from it and could apply it to the second child. I just learned from him and just try to be better as he got older. But he told me, he was like, "Mom, you've had years to do this math. Like I just had this year. So, you got to give me a little bit of grace, basically." And for him to tell me that, I was like, boy, you're right. Dang, I got to get it together. You know what I mean? Because like you said, because you got it one way, you're expecting them to get it one way, or because you got it easily, you're wanting them to get it as easily. But again, it just depends on, how it's presented to them and the tenseness within that situation. So thank you both so much. So I want us to get into tonight HYS strategies. I've been talking about this with teachers as we're preparing to go back to school. Now I want to talk about how can we use this at home though, because we've been talking about empowering parents, because at home is where a lot of this stuff needs to happen so that the change that we want to see in classroom is really possible, because the teacher can't do it all. So I'm bringing up I want to share some things with you guys that I shared with my teacher this week. Hey, Erica. So we talked about these HYS strategies that we're focusing on within our district. And we talked about the fact that these are not the only ones that exist out there, but we focus on these because of the effect size. So they say that implementing these Implementing these in the classroom has a very strong, positive relationship with the student outcomes. So you can look over the screen, you can see the effect size, you can see those comments, high order thinking. We're talking about the kids analyzing, evaluating, and creating. Distributed summarizing, that's when they're acquiring the knowledge and the skills. And collaborative pairs, that's basically where they're working together. We're making the kids accountable. So when you think about high order thinking, you're thinking about asking kids questions that are beyond just recall. And when you think about distributed summarizing, you're giving the kids a moment to, one, process something on their own, talk to a peer about it, and then us talking about it as a group. Or it could be something like Jigsaw, where people become experts on something and now they're sharing their expertise with people in the classroom. And then obviously collaborative pairs kind of overlaps in it. So I want us tonight to think about how can we use these strategies and empower parents to use them from home, even if they're not a math teacher by day. We want to give you guys some things that you'll be able to walk away with tonight to use with your kids. So, you know how I like to use examples. So we about to go into an example. All right, so we talked about equivalent ratios at the very, very start of our time together when we started going live. I'm gonna come back to it because I think it is a accessible concept. Okay, so what are equivalent ratios? So I want us to take a look at these, the ratio 5:3 and 10:6. And I want you guys to put on your student hat and tell me, what do you notice or wonder about this statement?
They both have a colon.
Okay.
Yeah. It's hard to put on the student hat because I'm trying to think what I would be thinking if I was a student just being introduced to this.
Okay.
So let's say I recognize the pattern that 5 is half of 10 and 3 is also half of 6. So the numbers in the first ratio are half of the numbers in the second ratio, the corresponding numbers in the second ratio.
I like that. I'm gonna put on my EC hat.
EC, what's that?
Exceptional children.
Okay.
Look, I done heard so many different terms for it. So I think a kid might say,
I'm writing what we got in the chat, the bigger numbers in the front.
that's exactly what I was gonna say next.
Mm-hmm.
Okay.
Oh, I might say, does this have anything to do with telling Tom?
Ooh,
Because of the colon.
that's a good one.
So I'm gonna put it over here. Is this time related? That would be interesting for a kid to say, but I understand exactly why they would say it.
Mm-hmm.
So what other wonders, what other questions could a kid have?
Oh, I know. I got something else. How
Go ahead.
how they gonna be equivalent when they're different numbers?
I like that.
If I know what equivalent means, I'm assuming I know what equivalent means that they have the same value, but how can they be equivalent if they are different numbers?
Okay.
Mm.
Okay.
Excuse me.
Somebody said, does this have something to do with common denominators?
Oh, I like that one. I got a good one. This is probably a middle level student. Can we write those ratios in a different form?
Okay. Can I write it differently? Okay. Okay. All right. Cool. So I think we got a lot. We got a lot here. So next, keeping in mind what we got here, all of our notices, we noticed that there's colons in between them. We noticed that there's a pattern. The first ratio was half of the second ratio, which means the second ratio is what to the first?
A multiple.
Right? It's double, right? Yep.
Yes.
And then we also had, I noticed there's a bigger number, the bigger number is in front. Questions were, is this time related? What is an equivalent ratio? What does it mean to be equivalent? How are they equal if the numbers are different? Does this have anything, I said, does this have anything to do with common denominators? And can I write ratios differently? Okay. So some other questions that I got when I did this for my teachers was, what are ratios?
That's a good one.
What do these numbers represent? Like, does it have to do with anything? So those are some other questions that we could have thought of. All right. So again, the statement is the ratios 5:3 and 10:6 are equivalent. Now, one of our questions is, how were they equivalent if the numbers are different? So can we talk about that a little bit? How are they equivalent if the numbers are different?
Equivalence, I would go into details about how equivalence means things that have the same value. And so I might even use the example of, hey, Sean over here has $1 and Keisha has 4 quarters. Do they have the same amount of money? And because we know that 4 quarters equals $1, then they have the same amount, but it's just a different number of coins.
Okay.
Or currency, rather, in this case, because we got a bill and then we have 4 coins.
Mm-hmm. All right. So I want y'all to pay attention to the first strategy I just used. So the first one was, I asked you to notice and wonder about what you saw. Okay. Now I'm giving you 2 additional questions. I want you to use what I initially gave you and compare it to 2 other statements. And the question is, are they equivalent to the original statement? So I want you guys to take a moment to think about it. We're going to pretend like we in the classroom. Take a moment to think about it. And then I'm going to ask you for your feedback in just a minute. All right. So if we look at number 1, thumbs up if you feel like that one is equivalent. Okay. Number 2, thumbs up if you feel like number 2 is equivalent. Okay. So I didn't see any thumbs for the first one. So can you guys help me understand why you didn't put your thumb up?
Not the same relationship.
Okay, tell me more.
So when I look at, well, am I still a student or?
Yeah, well,
Okay.
yeah, it don't matter.
So I'm looking at it like first number matches up with first number, second number matches up with second number.
Okay.
So I'm thinking, what does it take to change the 5 into a 15?
Okay.
Using multiplication, not addition or subtraction, but using multiplication. So I know I multiply by 3 to change the 5 into a 15. So that would be, okay, as a teacher, I might say, constant of proportionality. What's some other terms for it? Scale factor, I might say. But then the 3 should match up with the 12. But in order to change the 3 into a 12, I got to multiply by 4. So those numbers don't match up. Because I got to do basically I got to do more to the 3 than I got to do to the 5.
Okay.
So I'm not doing an equivalent like action.
Okay.
Because the 5 is getting tripled and the 3 is getting quadrupled.
Okay. So then since those factors are not the same, what does that mean for the ratio?
That means that the ratios aren't equivalent because the factors aren't the same.
Okay. So then what about the 10-6 when I look at that in comparison to 15-12?
So with 10 and 6, so 10, to make 10 into 15, you multiply by 1.5.
I'm listening.
But to make 6 turn into a 12, you can double 6 to make it into a 12. So again, so we're doing more to the 6 than we are to the 10. Right? Because we're multiplying 10 by 1.5 and multiplying 6 by 2.
So then this is what I would ask. Did I have to do what I did with the 10-6 once I did what I did with the first ratio?
No,
Why?
because if we accept that the 5 to 3 and 10 to 6 are equivalent ratios, it's almost, so this is almost like this, I guess not almost, it is using the transitive property. If 5 to 3 is not equivalent to 15 to 12, but 5 to 3 is equivalent to 10 to 6, then 10 to 6 can't be equivalent to 15 to 12 because they would all have to be equivalent to each other.
Right.
It's,
Okay.
yeah, it's like three people with it's like three people, you talk about their ages, right? So if I'm just as old as him, but then I'm younger than this other guy, then the original other person also must be younger than that other guy. So then I can't say like, well, are they the same age? Because I already know they're not the same age because me and him are the same age,
Right.
but I'm younger than that other guy.
Right.
So we got, yeah, so we're locked in, we're connected. But me and the other guy, he got a different age.
Right.
So it's like something similar to that.
All right. What about number 2?
You want to take this, Dana?
Got it. So similar to what Akil was saying in the first example, right? I would look at and see, okay, well, I already know that if I go from 5 to 10, I multiply it by 2. And then I also know that if I go from 3 to 6, I multiply 3 times 2. So then now let's go from the 5 to 3 to the 30 to 18. So once again, what do I need to multiply 5 by to get 30? In this case, it's 6. And then I ask the question, well, what do I need to multiply the 3 by to get 18? And the answer is also 6. So now to kind of keep in line with the terms Akil was using, if we use that 6 as a constant of proportionality or a scale factor, then I know that these would have equivalence, because if I multiply my two original numbers in the original ratio by the same number, in this case that same number is 6, then I get the 30 and the 18. Okay. When we look over to the other one, we want to basically do the same thing. Now we can keep it as Akil mentioned, and think of the transitive property, right? If thing 1 is equivalent to thing 2 and thing 2 is equivalent to thing 3, then thing 1 is equivalent to thing 3. Okay. So here, same thing. I start with 10. What do I multiply 10 by to get 30? In this case, it's 3. So 10 times 3 is 30. And then I ask the same question. Well, can I multiply 6 by 3 to get 18? And the answer is yes in this case. So now the 30 to 18 is equivalent to the 5 to 3 as well as the 10 to 6.
Nice. Nice. Okay, so we're gonna pretend like I asked the class, y'all, the original question. Y'all noticed and wondered. Then we just did these 2 questions. Now, this next part is where I'm going to see if you really understand what it means to be equivalent ratios. So I'm going to ask you to give me 2 more examples that would be equivalent to 5 to 3.
100 to 60.
Okay. Walk me through it.
So 5 times 20 equals 100. And 3 times 20 equals 60 last time I checked.
Okay. Let me get another one. Akil.
20 to 12. And
Okay.
I'm multiplying each of those, the 5 and the 3, by 4.
Okay. So we got 2 more. We have a good understanding. We feel like we have a good understanding of what it means to be equivalent ratios. So then now I'm gonna hit you with this. We're going to do a routine where most people, when they see this, they think of the Freyer model. But what we're doing
That's
is
immediately
stronger.
what came to mind.
Right. But what we're doing is stronger and clearer each time. So after we just did this, now I want you to think about what just happened? What did we just do? And I want you to construct a definition for equivalent ratios. Like, what does it mean to be equivalent? What does it mean if it is not equivalent? Okay, we're not going to do this, but I'm just going to walk you through it. So that would be the first part. So I will give you like 2 minutes to do that. Then I'm going to have you to meet with one partner, and y'all are going to share your pre-writes. The part y'all are going to listen to each other, and if you have an aha moment like, oh dang, I ain't think of that, you're going to write that down. Then you're going to switch again with another completely different partner and do the same thing. Any aha moments, you're going to write that down. And then you return to your seat to do whatever your final revision is. How do you know when ratios are equivalent and when they are not? Okay. So I want y'all to think about everything that I just did. Remember, we was talking about high order thinking skills. We were talking about distributed summarizing and collaborative pairs. So from what we just did together, where did we see those things in what we did?
What exactly is distributed summarizing?
That's where you have a moment to think to yourself. Then you would meet with the partner and you can share it out. Or you could become like an expert in something and share that out. You could think of it as simple as think, pair, share, turn and talk, something like that.
And then you said the last one was collaborative pairs.
That's just where you're working with someone. You're accountable for acquiring knowledge alongside a partner. So where did
That's
y'all
a new
see
term.
those
I got to
three
put that
things?
in my notes.
What'd you say, Dana?
I said that distributed summarizing is a new term to me. I got to put that in my notes.
That's Open Up. Well, that's where I learned about it, is from Open Up. But I always tell the kids, what does it mean to distribute? And then they tell me that. But that's what we're trying to do. We're trying to spread the understanding throughout the classroom.
And that's why I like the term, because we can relate it to like the distributive property and things like that. I think it's a good example. So if we go from our wonders, I'll start by going from our notice and our wonders, actually. There is a progression. Let's say, so for example, I said initially that there was a large number and then a small number in both cases, right? I know that was one of the things we said, right? So if I go from that is very, very general, a very general notice. But then I get over to the wonder and I might say, okay, well, how do or whatever question I might be asking, whether it's out loud or it's in my head. Well, I'm going to think about, number one, how did the teacher respond to, let's say, Akil and I are classmates. How did the teacher respond to Akil's notices and wonders, which the teaching strategy is you should respond to them the same pretty much, right? But naturally, we will say, oh, okay, I didn't think about that or something like that. And so now, what is the gap between my notice and my wonder and Akil's notice and wonder from a student perspective? So then now I go through, I see y'all do the examples and things like that. And I'm like, oh, okay, I think I got it. Now I go talk to Akil with the distributed summarizing. And I might say, hey, Akil, I noticed 10 is a multiple of 5. And I noticed that 6 is a multiple of 3. But I didn't look at them from the perspective that you looked at them. I looked at them left to right, horizontally. I noticed that you moved them and made them vertically. And then once you made them vertically, I saw fractions in my head. But I saw a fraction from the first number in the first ratio, it being the numerator, and the first number in the second ratio being the denominator. And then I saw the first number in the first ratio being the numerator, and the second number in the second ratio being second number in the first ratio being the numerator, and the second number in the second ratio being the denominator. Now I'm able to connect those understandings as a student to say, oh, okay, 5/10 is equivalent to 1/2. 3/6 is equivalent to 1/2. So then now I gained some understanding. It was just I took a slightly different path than Akil, but I was able to see his thoughts and his work and say, oh, okay, well, if I'm on 95 going north to DC, I can stay on 95, or I can get on 295 and go around Richmond to beat the traffic. I didn't know why Akil's always, every time we go up here to Baltimore, Akil, man, you always take 295. Why you go around that way instead of the, straight line? Yeah, my man, but I've been doing this for 7 years, and I always realize that whenever I get to Richmond, it's traffic. So I slow down, and then when I started timing it, oh, okay, yeah, I'm still gonna get to Baltimore in the same amount of time.
Okay. So before you respond, Akil, I want you to think about what we did, our whole little process that we did. Where do you see all of the high yield strategies? So we had high order thinking skills, distributed summarizing, and collaborative pairs. Where did you see it within there?
I saw the distributed summarizing in the notice and wonder, a piece of it.
Okay.
Because as I mentioned, we noticed and wondered different things.
Yeah.
List those terms again.
High order thinking skills,
distributed
summarizing, collaborative pairs.
Okay. I want to touch on the high order thinking skills. I think the higher order thinking skills was when Akil used the example of the transitive property, and he compared it to 3 people's ages. So to me, that was a higher order thinking skill, because I was playing the role as if maybe I didn't know, or maybe I just didn't remember what the transitive property was. And that could simply be because maybe the teachers that taught it to me, it might have been a couple years ago, or they may have used a different term. They may not have explicitly said, hey, this is the transitive property.
Right.
You know what I'm saying?
Okay, what you got?
I would first like to say that when I was a student, I hated these exercises.
Okay.
And I'm still trying to figure out, I'm trying to pinpoint exactly what is it about either the exercise or me or both, or just the way I navigated the classroom as a student, which made me hate these exercises. Because
so before you go deeper, when you say these exercises, what you mean specifically?
Having the, like, anything involving a like think, pair, share,
a partner.
Yeah, like, and I think so. I started out like that as a student, so that's why a lot of times in PD, I was already conditioned to not like a lot of the PD activities. The math activities were for the most part kind of cool, but the general PD activities, a lot of times as a younger teacher, when I didn't see the value in it, I think I allowed myself to kind of zone out, because I'm thinking back to like when I was a student in class, and like, because I mean, maybe it's got something to do with me having a strong algorithmic basis for math, and just, where I'm like, listen, just give me the formula and let me do the problems. Like, I don't want to think about anything else. Like, this will bother me, because I'd be like, well, I got to worry about all this. Like, I don't, and also I think part of it is like being a selfish student and being a selfish person. Like, I was selfish as a younger child. Like, like, so I'm like, I don't want to work with nobody else. I don't. That's why I never fared well in group work. And I remember being in science classes where I think I missed out on a lot, because we'd be in the lab, whether it's chemistry lab we had to do, or something like that was group oriented, and I kind of would be like, I don't really want to work with other people. I just want to do my own thing, but I couldn't do my own thing because everybody had their own responsibilities. So I would kind of just, I would be so focused on the fact that I didn't want to be working with other people, and I would miss out on I remember I would miss out on the opportunity. But of course, back then I didn't see it as an opportunity. I was just like, man, this is in the way.
Right.
I don't want to do this. But I think that, yeah, now I lost my train of thought. So what am I supposed to be reporting out on? Like what we discussed in the previous.
So I'm a because I have this other part that I want us to see as well. So with the high order thinking skills,
Yeah.
basically this question that's on the screen is an example of that. So now we're having kids to compare and connect based on their experiences. So based on what we just talked about with the ratios, how do you know when it is equivalent and when it is not? So that is an example of us using the high order thinking. Distributed, summarizing, and collaborative pairs comes when they get to talk to their partners. Now, it's probably harder for y'all to answer the question because we didn't go through the routine, but that's where you would see those. But I'm gonna tell you this. Imagine if I was a student that came into your classroom and you posed these questions to me, asking me what are equivalent ratios, and I was one of the kids who hung in the back, didn't answer any questions, wasn't disrespectful, but I really wasn't engaged. Like I wasn't answering any questions. I also didn't understand what was going on, and you miss me.
Right.
Now you give me an opportunity to do this pre-write. There's nothing on my page because I have no idea. I'm lost. But then you give me an opportunity to talk to Dana. And then Dana says something that makes sense to me finally. After me sitting in this classroom for 20 minutes, finally he said something that makes complete sense to me. And I'm like, oh, I get it. But now you got me going to talk to now Akil. And I have to share with him what I learned, my aha moment. When I share that with him, now we go into a whole nother level, allowing it to be retained because now I'm speaking, I'm sharing it, right? I'm teaching somebody else something that I learned. So I just went from not knowing anything that went on to now actually being able to share something that I understand. So when I go back to my table, I'm now able to write a final version. So that's this strategy here. That's why it's helpful.
Yeah.
The
Yeah.
students who might not know. But
Yeah.
then also in my class, some of the high flyers, they love teaching. They love an opportunity to tell somebody they know something.
Yeah.
So when you
Yeah.
give them an opportunity, now I wouldn't necessarily pair them with someone that's really far away because that could be frustrating. But someone that's kind of like right near them, now they're kind of debating about, well, no, it should be this, it should be this. Oh, that makes sense. I didn't think about it that way. So they're still kind of sharpening each other. Okay.
Yeah.
That makes sense.
Yeah.
All right.
And I posed this quick question
Mm-hmm.
based upon what Akil said about his experience as a student, and it made
Mm-hmm.
what came to mind was how much of a student's resistance to collaborative work is due to lack of trust, whether it be trusting themselves and their own knowledge, or lack of trust of other students' knowledge, versus their personality traits such as introvert, extrovert.
Mm-hmm.
Because what the reason that came to mind was I didn't trust other people's work. I knew what I was doing. Very standard algorithm type of math student. But I did like group work because I'm like, hey, look, this how we gonna do it. And then now we can talk.
Mm.
So versus Akil might be a more reserved student who doesn't, doesn't may be concerned about the embarrassment of getting it wrong because that happens so often.
Yeah.
You know what I'm saying? Or so he could be that kind of student, or you could have the student that say, "Oh, I got the answer. Like I don't need to work with nobody. I got an A." You know what I'm saying?
Right.
I think these are things to consider from the teaching side as well as from the parental side.
Yeah.
Sometimes you might have a student who is more reserved and they don't like collaborating a lot with other people because they don't want to deal with the foolish. I know the foolishness. I know each of us have a job in this class. My teacher has different jobs for each group member, and they're responsible for this part of the collaboration. But the teacher put me with Dylan, and Dylan never does his work. Dylan halfway comes to class and things like that. And I'm like, dang, I got stuck with Dylan in my group, man. I done reduced down to an 80 already because Dylan ain't gonna do nothing.
Hopefully the teacher's gonna be mindful of that and she's gonna know her kids, and she's gonna know that you're gonna respond in that way, that you're even gonna be thinking that way. So I ain't even gonna put Dana with Dylan, because I already know Dylan, he about to pee Dana off, and I Dana gonna be mad. So I ain't even about to put them together.
Now I ain't answering no more questions.
Okay, so now I want to think about the parent side of it. We just went through it from a teacher aspect, but how can parents utilize these strategies at home? And I'm just going to revoice them. So we talked about high order thinking skills, which could be just questioning. We talked about distributed summarizing, so just sharing out what you've done, and then collaborative pairs where you're just working with someone. Think about the specific routines that I use. So like notice and wonder, having you to work on something and now comparing that understanding to something else, and then having you to create your own equivalent ratio. So how can parents use these different things at home, even if they're not a math teacher? How can they use it at home to support their child?
Just like
So I like, go ahead, Q.
like just go through the process, like, just have try to have a conversation just with your children. Just think of it as a conversation for starters. Like let's talk about, ratios. Like if you they bring home the homework assignment about ratios, first try to make sure you have some understanding of it, and then say, let's talk about this. Because I think one of the benefits of being at home, if as a parent, if you have the time, you're not under the time constraints of the teacher in the classroom, because y'all can just kind of sit there and just chop it up. Like, what you think about that? Like, does that make sense? Just like the same way you would talk about like a sporting event or like something on television. It's kind of, you can talk about it in a casual way. Like 5-3 and 10-6. Like, are those equivalent ratios? What makes them equivalent? Why are they equivalent? Like that question why is so powerful. Like keep asking why. Like why does that make sense? Because I could tell you they're equivalent ratios. Now you tell me why. How you know I'm not lying to you?
Right.
And then what's the rule that you come up with to make that make sense? And then we get into the other examples. Like what are some other equivalent ratios? And then what are some, like, and if we say 15-12 is not equivalent, well, why is it not equivalent? Because I think one of the things that happens in classrooms sometimes, and even at home, if you help them with the homework, is we may not take advantage of the wrong answers, take enough advantage of the wrong answers, because I think it's very important to explain why something is wrong, because that really tests your understanding. Like if I say, well, 15-12, it's not equivalent. You say, okay, well, another thing, and I think this is timely, in tutoring sessions, I'm constantly telling students, like, so I might get on your nerves when I'm asking you why constantly, and I'm asking you to explain yourself. But we're in the day and age of Chat GPT and AI. So I'm thinking that the way formal education is going is like, now it's like it's even easier. I mean, people could always cheat in the past, but now it's even easier to just, get the answer. So I think as a response, what's going to happen is students are really going to be tested in terms of by being able to explain why. Like, how did you get your answer? Why is this a right answer? Why is that a wrong answer? Because now it's like I be like telling them like yo, like I don't care about the right answer. I want you to tell me how you got it. Like, because that's really where it's going to be at. Like you being able to explain yourself, explain why this is correct, versus or explain why this is incorrect. Because everybody got a smartphone now. Everybody can get Mathway or any of those other apps where you just take a picture of the problem. It's going to give you the steps step by step. You won't even just give you the answer; it give you everything. But if you can't explain it, most of the time, most people may not be able to explain those steps. So like the whole game is going to be, can you explain like why this is the right answer, like step by step, and can you explain why that's the wrong answer? So I think for parents too, just having those conversations, just having conversations with your children about like, well, why is this the right answer, or why is that the wrong answer, or that's what I'm thinking.
Okay.
So the first thing I want to point out something Akil said. What's the rule to make it make sense?
Mm.
That's powerful, because the way mathematics is, and Lanisha has really helped me grow in this, with her diligence towards learning and understanding new math. So shout out to Nisha on that. But because they're deriving formulas now versus we came through, it's like, hey, here go the formula, plug and chug. But the other thing in what you said that I'll speak on is when we have that conversation at home with our children, a lot of times we don't realize we can help empower our child by having that conversation. Hey, DJ, can you give me an example of equivalent ratios? And DJ might be able, or I might give him the same problem. And what do you think? Boom, boom, boom. He gives me an answer. He says yes. And I say, well, where's your work? He was like, well, I know it's equivalent ratios because if I take 5 and multiply it by 3, I get 15. If I take 3 and multiply it by 3 and get 9. Okay. So, okay, well, where's your work? Well, I don't know how to show the work. The words that you just said, how can you write them on paper?
Mm-hmm.
So now the opportunity to create these higher order thinking conversations is simply, now we've talked about the math at first, but now let's talk about it in relation to band. If you're a band student, let's talk about it in relation to sports. Let's talk about it in relation to Legos. Let's talk about it in relation to the things in the bedroom, the things in the kitchen, the things outside the home, all of these things. Remember, the highest level of Bloom's, they're creating and analyzing. So I think that that's where parents get an advantage, because now you get to make an impact that maybe your child couldn't do. Maybe your child, that your child's teacher couldn't do. You were able to show your child how to take what they're verbalizing and then write down the mathematics, and we can always brush that up. You know what I'm saying?
Yeah. So one thing that I think parents can do, like at the beginning when I asked you guys to do the notice and wonder, that is a very low floor task. Like anybody can walk in and tell me something that they see on the screen. Okay, anybody can do that. Now, Akil said, if you don't know about the topic yourself, well, check this out. You and your child can go research. So go research what a ratio is on your own. And now let's come back together to talk about, what did we find out about a ratio? Let's compare our notes from the things that we found out. And then once we feel like we have an understanding about what we researched, we can apply that to whatever the homework question is. And then, like Dana just said, now let's take it a step further. And now let's create something that is related. So I think for parents, that's how they do it. Like, just keep it simple, have the conversations, ask them, what do you notice? I just realized I spelled that word wrong. Akil, why you didn't tell me when you was checking this that I spelled focus like that? What is that?
I missed that one. I was lacking. I missed that one.
Got me up here looking like a nut. Oh my gracious. Okay, now I'm so distracted. So
wait, but this is a teachable moment, right? Because we can learn. So what's the lesson that we learned from the mistake?
The lesson is that I am going to always go back and proofread my stuff, because Canva is a hater and does not underline it to let me know that I spelled it wrong. And I'm mad about that.
And the other lesson is those brain teasers that they put on social media that tell you how our brain automatically puts together the word that's the right word. So which is why we miss letters and things like that.
Like I knew all the letters was there, right?
We do the spell check automatically. Our brain does the spell check already.
Absolutely.
Okay. So we can move on. Just derailed me. All right. So again, parents, make sure that you're having you're having conversations with your kids. Asking why can take your child a very, very long way. Making sense of the rule. Like, why does this make sense? What is your evidence showing or representing your thought process, maybe on paper, using visuals? And if y'all don't know, go research it and then come back together and have a conversation about it. So now this takes us to the next part, the CRA model. So we're talking about concrete, representational, and abstract. And I think a lot of times people confuse these things. So concrete, we know, hands-on. Representational, those are our visuals, models, drawings, things like that. And then abstract is when we get to symbols, equations, formulas, things of that nature. So I want us to look at some things together, and then again, same process, figure out how can parents do this at home. So we're looking at this situation. So Diego has 7 packs of markers. Each pack has X markers in it. After Lynn gives him 9 more markers, he has a total of 30 markers. So the objective here is to create a tape diagram. That's the objective, to create a tape diagram. Dana's head has dropped. I don't know what that means. But that is our objective, to create the tape diagram.
I thought you was going to say just create an equation.
We're going to get there. We're going to get there. Right? So remember, this is the CRA model. So
I got it. Okay. Yeah. I think I can make a tape diagram of this.
All right, hit me with it. I'm ready.
Does it have to be a double?
No,
or just a single tape?
One. You just
okay. So we're gonna draw a long rectangle. And we're going to break that rectangle down into 7 sections.
7 total sections?
Yes. So
Okay.
I'm gonna make 7 smaller squares within the rectangle, or rectangles within the rectangle.
Okay.
However, I'm gonna partition it into 7 different pieces.
Okay.
Yeah.
Okay. Tell me about my spacing.
Okay. So your spacing 1, 2, 3, 4, 5, 6. We're gonna need 1 more line.
Okay.
We want those spaces to be the same size. Hopefully, they don't have to be perfect, parents and students, right? But we notice the one on the far right is a little larger than the other sections, right?
Okay.
So I'm gonna put 9 in there. That's my 9. All right. And then I'm gonna put X's in each of the other spaces to the left. All right. Now, I actually am gonna do a double tape diagram. Put another one under that one that is a open. There we go. And we're gonna put 30 in that rectangle.
Okay. So
did I do well?
Okay. So remember, we talking about the CRA model. So what we just did, where would that be in the model?
I would say representational.
Yeah.
Okay.
So
all right.
So if, let's say I needed to take a student back to C, what would I do?
I'm going to get 7 different items that are the same size. I'm going to get 7 different items that are the same size. And then I'm going to get some other item that is a different size from those other items, right? So I got 7 pieces over here that might be number cubes. You know what I'm saying? Okay. And then I'm going to get another something concrete. It might be like, I don't know, because it's 9, so I wouldn't say a 10 block, but you got the individual cubes, then you got the 10 blocks, right? So let's just say I got 7 individual blocks and then a 10 block instead of using 9. Right. But in this case, we'll figure out a way to make it look like did you get the attachment ones? You know what I'm saying? And put those next to each other. But I want them separate, maybe one on the top, and the group of 7 on the top and the group of 9 on the bottom, so that I know these 7, they represent the same size. We don't know what numerical value each one represents, but we know we started with those and then we added something to it to get a total of 30. And so then now we might even have 30 whatevers as well. So you got 3 groups. One group has 7, one single thing has 9, and then another group of 30.
Okay. So if we're going back to C, what's the whole point? What are we trying to get?
We want them to be able to touch it. We want them to be able to, like, that's why I said number cubes, because they can touch it, they can move it, and things like that.
So objects, things. Now, let's say I want to take them up to abstract. What would I do?
Create an equation.
Yeah, give them the equation.
So, yep. So then I'm going to ask the kid, how many X's do you see? And they're going to tell me 7. Now, why do you think it's important for me to ask them in that way?
To me, I think it's connected to combining like terms.
Because sometimes when a kid sees 7X and you ask them how many X's do you have, they'll say 1.
1.
Yeah.
They'll say 1. So I have 7 X's and 9 for a total of 30 markers.
Can you say that again? You said 7X is what 9?
And.
Very important.
And. So if we're doing concrete, we got something hands-on. So some objects, I can have 7 packs. I could have 9 markers. And then the kid is trying to figure out what's in each pack. If I got a total of 30 markers, we got representational with our tape diagram in the middle, and then we have our equation for abstract on the end. Now, one thing that I've seen happen is teachers will think that we got to start here and slowly advance kids, but you can actually show them these things or do these things kind of simultaneously and giving kids the access, because some kids are beyond objects and are ready for the equation or ready for the representational, and we don't really want to hold them back just because the thing says we need to be at objects. Okay, so boom, we got that one.
Can I talk about that one real quick?
Oh yeah, sure, go ahead.
So I have older students, right, that are like 30, right? And sometimes they hit me up and they remind me of how much of a Nas fan I was. And I used to, we would talk about rap in class. And this problem makes me think of the song off of Stillmatic, Rewind, where he like tells the whole story backwards. Like the story, like he's telling it from the end of the story to back to the beginning, right? So when I saw this, I started at the end of the word problem. So that informed how I drew my tape diagram. So I just did the single tape diagram. I drew a long rectangle. And at the far right of the rectangle, I put 30. But then I knew that Lynn gave him 9 more markers. So I'm working backwards. So I'm like, okay, well, before Lynn gave him 9, he had 9 less. So then I drew another like vertical line to represent the 9. So then I had a block for the 9. So then that takes me to 21. So I wrote 21 on the tape diagram. And then I knew that each pack, Diego had 7 packs of markers. So before he got the 9, he had 7 packs. So I break up the remaining part between the beginning of the tape diagram and the 21 into 7 equal pieces. So I just had like one long tape diagram. And then I got my X blocks, like how you had with Dana's explanation, and then the 9. The only difference is that between the 9, instead of having it, I guess, stacked, it's one rectangle.
So let me ask you, you have the 30 in the same box as the X's and the 9s?
Yeah, but the 30 is at the end. So what it means is that everything represents 30. So it's like it's like the far left is 0 and the far right is 30. At the far left is 0 markers. So it's almost like it's like a number line. It's like modeling a number line going from 0 to 30.
But is there anything that separates the 30 and the tape diagram, or you literally have 30 inside the same rectangle?
Vertical bars. So the vertical bars. So you see how like the 7 X's, how those are inside, like those are little rectangles inside, and then I got another rectangle for 9 inside of there. But then imagine if you took that 30 where the rectangle where the 30 is.
You come over here like that?
Yeah, put that over there. And that block would represent 30 would be at the end of it. It would be to the far right. But it's more like a
30 over here?
Yeah, because 30 wouldn't be inside the box.
Okay,
30 represents the maximum amount.
Gotcha. That's what I was trying to figure out, whether or not it was in or outside of the rectangle.
Yeah, because again, when I read this at first, I'm like, okay, well, the way I would figure this out, especially if I was trying to come up with an equation, I would work it backwards. I would think about it like starting at 30, and then okay, so what happened before Lynn gave him the 9 more markers? So then he had 21 before she gave him the 9, because he had 30 at the end. So 30 take away the 9. And then that's why it's like I thought about that, like that Nas connection, because he's like, I spit a story backwards, it starts at the ending. Bullet goes back in the gun and like all of that, right? But yeah, so then it's like 7 packs of markers. Each pack has X markers in it.
Mm-hmm.
So 7 groups, and each group is X. So yeah.
Okay. Thank you. All right. Second to last one. Skate rink charges a group rate of $9 plus a fee to rent each pair of skates. A family rents 7 pairs of skates and pays a total of $30. So again, we're talking about the CRA model. And the objective for this particular one is the same as the last. We want to represent it. So how could I represent it?
Is this the y equals mx plus b that nobody ever has to use in life? Is that what this is? The infamous y equals mx, the useless y equals mx plus b?
Woo!
Is that what this is?
Listen, you know what? We be starting trouble. We be starting trouble. I'm gonna start with concrete this time.
Okay.
I'm gonna get out. I'm gonna go in my dollar box and get a bunch of dollars.
Okay.
And I'm gonna create 7 stacks of $9. Wait, hold up. I'm tripping. That is so wrong. Because teachable moment. That says a group rate of $9. So I gotta put 1 stack of $9.
Okay.
And
yeah, stack of $9. Okay.
And then I'm probably separate it and have another stack of $30, right?
Okay.
And I probably would take like some index cards and 7 different index cards and leave them blank.
Okay.
Right? Because it says skating group rate. So it's $9 for the family. There's a fee for each pair of skates. They got 7. So each index card represents the fee.
Okay.
I'm gonna get $30 and put it in another stack. So I got a stack with $9. I got a stack of 7 index cards or 7 blank somethings. And then I got a stack of $30.
Okay. How are your stacks related?
I am going to say that the stack of $9 plus the stack of blank index cards has to be equal to the $30. So maybe I would do like a vertical line, or I might put them in one bucket, the $9 and the blank index cards in a bucket, or let's just say on a plate, right?
Okay, I'm listening.
And then I'm gonna take the $30 and put it on another plate. Yep, there we go. And that's a great question, because we want to when we're doing this concrete, we want to make sure that we're able to show like the scales. You know what I'm saying? So we want the student to know that the stack of $9 and the index cards has the same value as the $30. Okay, because that I believe that's going to lead the child to understanding, when we look at the problem, a fee to rent each pair of skates, that each tells me for every, it's just like saying every.
Right.
So the value that I end up writing on those blank index cards has to be the same value for each index card.
Okay. All right. So for C, we done broke out our hands-on equation. We got $9. We got some index cards that represent whatever that fee is per person. And then on the other side, we have a total of $30. And we did that all on our scale to show the equivalence. Okay, so that was hands-on. Now representation, what will we do?
I would do the same type of tape diagram. So I would put a long rectangle, draw a long rectangle. And in the rectangle, I would put, and it doesn't matter the order, but I would put the 9 in the first section. And then I would create 7 equal size sections on the right side. Perfect. And then the bottom long rectangle would be $30. Just 30. Yeah, 30. And I would put X's or some variable.
Okay.
There we go.
So you know what's cool about this too? This tape diagram, the way you did this one and the last one. If you take the tape diagram and you do geometry, if we do a what is it, 90 degrees counterclockwise rotation,
Mhm.
it models the concrete representation with the scale.
That's
Because
true.
because then the 30 going to be on the right side, and the
Mhm.
9 plus the 7x is going to be on the left side.
I
Mhm.
like that. I like that.
I thought one of y'all might think of doing the hanger diagram. So I was prepared to draw that because then that would have been like the scale too. But yes, yes. Now,
Yeah, we're gonna have to talk about hangers one of these days.
oh, let's do it. I love hangers.
Yeah.
Okay.
Because I know you could teach me some things based upon one of the conversations we had. So
Oh
then
yeah.
the abstract, I would say, okay, if we take the abstract from either the concrete or the representational, we notice that they're separated. In the concrete, we use the scale. So the scale is balanced. So what's on the left side of the scale has the same value. So that tells me I'll start with an equal sign for the abstract. And on one side of the scale or on the top part of this tape diagram, I have let's go with the equation. Let's say 9 plus 7x. Because I have 7x's and then I have a 9, right? And then on the right side, I will put the 30.
Can I ask a question? Would you ever recommend or like have students, instead of going to the 7x, have them write the x's out individually and then simplify the equation? Do you think that might ever helps certain students to be
Yeah,
able to see where this?
that's differentiation right there. So that now you just went to maybe your lower level kids or your kids that might be struggling. You know what I'm saying? Because you might still have a kid. Let's say this is a higher level math class, and not like let's say this is 8th, 9th grade, right?
Yeah.
And the kid still is struggling. They've had exposure to exponents, but that's a place where you can have a teachable moment to teach them the differences between exponents and how they're combined versus just regular like multiplication of the same thing by itself versus adding the same thing to itself.
Yeah.
So we would want students to understand that we're talking about length, right? So if we're talking about the total length, then I'm adding 9 plus x plus x plus x plus x plus x plus x plus x. So it's already there in a sense. Now, but like you said, there might be somebody that needs you to go a step further and still write that out. But we're hoping that they understand that that is a total length and that is that they're adding there.
Or even if they label it on the representational part, if you say like, well, how can I represent all those x's? What's another way to express that? Like the x's. And then the question would be, well, should it be, what's the relationship between the 9 after you write the 7x on the relational part? or representational part, I should say. What's the relationship between 9 and the 7x? Would it be 9 minus 7x? Would it be 9 times 7x? 9 divided by 7x? 9 plus 7, was it 9 plus 7x?
Mm-hmm.
That's
Man, as we talk about this, there's a lot of different things we can kind of weave together just from this. And I love the fact that you brought this out, Niche, because it shows how, there's so many different teachable moments within the mathematics when you're able to stretch it out and break it down. And this is for the parents out there. When you see strategies like this, yeah, it may take long. You might be thinking, why is it taking me 20 minutes to work out this problem with Johnny and these apples? But when you expand it out like that, now you get to the whole purpose of going from concrete to representational to abstract is so that they can see, because that's really what they're doing in school. In kindergarten and first grade and second grade and third, it's always manipulatives. But then when they get to like sixth, seventh, and eighth grade, they start pulling the manipulatives. And this ain't about like not having resources. They just start pulling them because they want the kid to eventually go from having these concrete items to being able to just see it and read it on the paper. Now, to what Akil said, working backwards, when they get an assessment or some independent practice, if they're given the equation, and let's say this kid may not even understand how to solve that equation, right? If they're able to work backwards and draw the representational on their page, then now that might give them a better understanding to where they can say, oh, okay, well, I got a total of 30. I know that 9, I take away from that 9, and I got 21, and then I got 1, 2, 3, 4, 5, 7 things of the same size that when I put them together, they equal 21. Oh, well, how many units is each individual thing to get to 21?
Right.
And like I said to somebody earlier today, I said all roads lead to knowing knowing your multiplication facts.
Bam.
Yeah. You got the 7x equals 21. You're trying to figure out what's x going to be. 7 times what equals 21. So you don't want to be in 8th or 9th grade, especially. You don't want to be in 5th or 6th grade or 4th grade sitting there trying to figure that out.
Right.
Like you want to just know it, like know it like the back of your hand. Like, oh, seven times. Oh yeah, 7 times 3. Yeah. And that's like parents watching this, that's a major source of frustration. So when you get to your child is trying to solve an equation and they're trying to solve for x when 7x equals 21. If they don't know that 7 times 3 is 21 off the top, then that's a fundamental issue. It's not even as much an algebra 1 issue. It's a weak foundation issue.
Right. Yeah. So imagining that we just took students through these examples and I pulled this is from 7th grade. There's, I think, a total of 4 questions before I show you this last one. There's a total of 4 questions where we took them through the C, R, and the A, or we made available to them the C, the R, and the A, right? So now when we get to this next question, I'm gonna read it, and then I want y'all to let me know what is reasonable for us to do with this particular question or statement. So Andre bakes 9 pans of brownies. He donates 7 pans to the school bake sale and keeps the rest to divide equally among his class of 30 students. So I'm gonna give you guys a moment to think about that and let me know where we're gonna start.
So is the objective for them to find out how many brownies are left over after he donates the pans, or are we trying to figure out how many brownies does each student get?
So the objective is still representing this.
Okay.
But remember, we're pretending like we did 4 where we went through the C, the R, and the A. So we did some hands-on stuff, we did some modeling, and then I showed you the equation. So now that we're at this one, what do we want to do to kind of represent this situation?
I'm gonna be a high flyer and I'm gonna just do 2 pans. So I'm gonna draw I'm gonna say I got two. We're gonna go plates. I got 2 plates or 2 pans. Let's go in the kitchen. I got 2 pans, and then I have 30 little marshmallows or something. But they're not gonna be on the pans. They're gonna be separate from the pans.
Okay.
But we're gonna do the scale, right? So I'm gonna say on one side I got the 2 pans, on the other side I have 30 brownies. So that's what I would do for the concrete.
Do we have 30 brownies though?
No, I got 30 marshmallows.
Oh, okay.
Same thing.
Okay. Okay.
I got 30 grains of rice.
But are
I
you
prefer the
saying,
marshmallows.
my question is, do you feel like the total here is the 30?
Oh. No, no.
Okay.
Because I'm thinking it's there's 30 students. Now I got questions. Are we including Andre in the 30 students?
Andre is just the baker.
All right.
He divided them equally among his 30 students.
So then now I'm gonna take and I'm gonna say the 31 because I gotta add me in there. And I love that about this question because that's where a lot of kids get caught up at. They forget to include the person sharing, the baker. You know what I'm saying? So they might create an equation with the wrong number because they forgot to include the Andre in this case. But I know that I gave 7 pans of brownies away. So I'm just left with 2 pans of brownies, right? And I got these 2 pans of brownies, and I gotta take these 2 pans of brownies and somehow how to figure out how to break them up into 31 sections. So then now I'm like, now we gotta mess up the pan. We can't even use pans. We gotta use a piece of paper to represent the pan. Because now I'm gonna take each piece of paper and maybe draw a section of break it down into 31 pieces.
Okay, so we ain't splitting it with Andre. We just splitting it against with his 30 students.
Okay, so
but then I want you to think about the hills, the circles, and the hula hoops that you're dancing through right now. Is it reasonable for us to draw this or to get some type of concrete manipulative? Is it
can I say something?
Practical.
As I was reading this, I was thinking of the 3 different representations: the concrete, representational, or the abstract.
Okay.
And I defaulted to this problem started to make me nervous as I was reading it because it was a little challenging, and I defaulted to what I'm most comfortable with, which is give me the equation. So I started like going for that.
Which would be
the equation I got. So I'm saying that he bakes 9 pans of brownies. He donates 7, so it's like 7. So I got 7 plus. All right, so I know it's gonna be 7 plus 2 is 9, right? The question is, how do we represent those 2 pans that he's dividing equally among his class? So it's 30 students, and because it says divided equally, 30 is gonna be my numerator, but I don't know how much. I don't know how many. I can't really explain this. I haven't figured out how to explain this, but I got 7 plus 30 over x equals 9. So the 30 over x represents the 2. No, 30. I got 30 over x. 30 divided by x.
I got you, but it's actually 30x.
Now I got to figure out why that is. Why is it 30x?
When I take those 30 pieces that I gave the students and I add it with the 7 that I gave away, that's going to total up to the 9 pans that I baked to begin with.
The total number of brownies, because what we're doing is so it's 30 students times, so x is the number of brownies.
X is the portion of the pan that each student gets.
So which is going to be a fraction.
1/15. Yes.
It's going to be a fraction. So it's like 30 times 1/15. 30 over, it was just 30 over 15, which is 2, which is where the 2 pans come from. Okay. So 7 plus 2, that's how you get the, okay. So it's not 30 divided by x, it's 30 times x, because x is the fraction.
Right. Now, we're not dividing the students. We're dividing the brownies.
Right.
And what I like about this problem is because Akil, immediately I started thinking about an equation, but then I was like, oh, okay, well, I need to start with concrete first. And that brings up the idea of multiple entry points too. That's what CRA allows. So by the time we've been working with CRA, working through CRA with the kids, then now we independent practice, and you give the kids a scenario and then have them come up with the C, the R, and the A. It doesn't matter where they start if they're able to show all three of them. Would you agree, Niche?
I agree. And
So I went and said, nah, I want to end. We've been doing it this way. We've been ending with the abstract. Let me try to start with the concrete first.
yeah.
So this is a cool moment because it's like, as you see, I'm talking and I'm like, wait, hold up. What I'm seeing in my head is not connecting with what I'm verbalizing. And that is what happens to kids a lot of times. So even when we go back to the Mythbuster, Mom Dukes, Pops, they might have one thing in their head, but they're having trouble voicing what's in their head and making that connection to the thoughts that's in their brain and the words coming out their mouth. And I think that's a very beautiful, teachable moment. So then it's like, okay, well, how can we now? We just partnered, okay, the distributed summarizing, and now Akil, when he came through and explained the equation, I was like, okay, yeah. He just wrote what I was thinking. I just didn't know how to write it. And I'm over here struggling, trying to figure out how to represent it. But in my mind, I was thinking, okay, I wanted the pans, the two pans left. I wanted them to represent the total amount of brownies.
Right.
And that's when it came to me like, oh, you got to divide each pan up into sections. So that was, I like that.
You use the word struggle, and I want to put productive in front of it.
Yes.
Because I really want more kids to talk about what you're thinking, like talk out loud. How do you view this? Like, what's the relationship between things? And then coming together just the way y'all did to come to an understanding. Now, the reason why I was saying earlier that we don't have to do those parts in isolation is because if we would have did all four of the ones that actually were in the activity, and they would have seen how we can do the concrete representation and the abstract, hopefully by this point, they say, well, it's not practical for me to try to draw out 30 of these pieces. Let me just go straight to the abstract, because now I understand the relationship between the quantities that are in the statement. That's what we would want to see happen. That's what we want to see happen. That's what we're trying to build them towards. So now we just did that. Now I want us, and I still spelled focus wrong. We gonna pretend like it's right. That just stressing me out here. I want us to still think about, like, how can parents do this at home? They're not math teachers now, but how can we utilize this mode going from hands-on to representational to abstract? How can we use this or components of it at home to support the kids?
Snacks for the concrete part.
Okay.
And the reward is you get to eat the snacks.
Okay.
I mean, even as a parent, I like the reward of being able to eat the snacks.
So tell me more. What do you mean? Dana, you muted too. Tell me what you mean when you say the snacks. What are they doing with the snacks?
They use the snacks to represent the numbers that they see in the problem. Like they could, I mean, I don't know if a parent, mom or dad, wants to bake 9 pans of brownies, but I don't know, maybe you bake 1 pan of brownies, or you buy some brownies, maybe do that for the problem. For the last one we did.
And as y'all answering, I don't want you to think about just these questions in general. Like if the parent was a high school, they got a kid in high school, or there's a parent who got a kid in elementary school, how can we support them with their math homework using concrete representational abstract?
Go get that big old bag of the variety bag of chips. And so notice you got a certain amount of Dorito Cool Ranch, certain amount of regular Doritos, certain amount of Cheetos, certain amount of Fritos, certain amount of Ruffles, things like that. They can use a bag of chips can represent a variable. Well, why? How does that represent a variable? We know what it is. We don't know how many chips is in there. But we do know what is the same is the number of ounces. Every bag of Doritos in that box is going to have the same number of ounces. Every bag of Fritos in that box, same number of ounces. Now, the number of ounces from the Dorito bag might be different from the number of ounces from the Frito bag. Right? And I like to Akil's point, the end goal can be, yo, you get to eat these. You know what I'm saying? So I think it's important for parents to be mindful of be strategic in the items that you select to use the concrete, because if we're talking about variables, they have to be the same size.
Yeah.
You know what I'm saying? It's like in each of these problems, whatever we were missing, the thing that represented the variable, they have to be the same, because if I got an X, a X, a X, a X, and an X, all those represent the same number. Why? They're the same variable.
Right.
So they have to represent the same number. So I think that it's important to do that. But I like what you said, Neek's like, wait, ain't nobody about to bake 9 pans of brownies. Okay, well, what can we use we can cut up some paper to represent a pan of brownies.
Yeah.
You know what I'm saying? But now you can use things. You actually start to teach kids how they can use things to get more creative. Now we're still, if we go take the paper and we fraction it off, partition it off, whether it's lines or whether however we do it to represent 1 pan of brownies, it's higher order thinking because the kid is creating. You see what I'm saying?
Yeah, for sure. And I don't want parents to see this and feel like, how am I going to be creating all the problems that they bring home? Like, I think it could be as simple as taking one question that your child is working on and figuring out, is there something in your house that you can use to manipulate? Is there an image that you could draw to model the situation? Is there a way that a rule that you can use to represent what's happening in the situation? That's it. And then finding a way to connect those things all together. Like, how can I represent this? I think is the major question. How can I represent whatever it is they're asking? Because a lot of times, because many of us, like you guys mentioned earlier, when we were in the classroom, it was like, here's the formula, go do your thing, instead of having us to actually think through it, which is why I feel like representing things is such a challenge for people. When you talk about hanger diagrams and tape diagrams and double number lines, that is a challenge for a lot of people because we weren't taught that way. But
it was a challenge for me as a math teacher.
But I think if we challenged ourselves to start to represent situations or think about even equations as really, it's not a drawing, but it is modeling of a situation. An equation is. If we thought about things that way and opened our minds, I really feel like we would be able to understand things on a much deeper level.
Absolutely.
Okay. Yeah. All right. Well, guys, we've been up here now for an hour and a half. We've talked about high yield strategies, high order thinking skills. We talked about distributed summarizing. We've talked about collaborative pairs. And we even went as far as to talk about the CRA model, concrete, representational, abstract, and how parents can use the things that teachers are doing in the classroom, how they can use them at home. I want to hear from y'all. What do we want to leave the parents with tonight?
Don't be afraid of productive struggle in this process. Whoever's watching this or whoever will watch the replay saw an example of all 3 of us tonight make mistakes. And we're considered experts. But even experts make mistakes. So as you're doing these things with your children, you're going to make mistakes. But use that as an opportunity to show students how to have a productive struggle, and use that as an opportunity to show students how just because you don't get something like done is better than perfect any day. So that's what I would leave them with.
Before you jump in the queue, I need to say something about what Dana just said. Making mistakes. Imagine if when you were working with your child, you made it seem like they could not make mistakes. Like making a mistake is just such a bad thing. Why are you missing this? Imagine how that child gonna be when they go to the classroom.
The
If
A
at
word.
home I can't make no mistakes, I'm supposed to be perfect. I ain't even gonna try when I get in the classroom because I
Yeah.
don't know these people. I'm not even gonna try. So make sure you're creating the space for your child to take risk with you, mom and dad.
Yeah.
Thank you.
Yeah, I just would, just add on to that, like, productive struggle for parents is something I highly suggest. I know it may go against our conditioning in terms of our definition of parenting, in terms of being like as a parent in relation to our children, we may want to be what is it, the omniscient, omnipotent force, so we don't want to expose that we don't know how to do something or like that we might make a mistake. So I think we got to kind of just deprogram ourselves because it's holding us back from developing ourselves as parents, as math teachers in the household, and it harms your child. It harms the child too. So we gotta kind of create like this collegial type of environment in the household, and the dining room table or the kitchen table, or sitting on the couch in the living room, or whatever. And like we're learning this together, and it's a marathon. It's not a sprint. So school year is starting up. So in some places the school year has already started, and it's a long school year. And if you got a child that's like in first grade or second grade, like they're gonna be in school, for many years. So if you develop that habit and they know, okay, we do math homework together and we do math projects together, then I think that's gonna pay huge dividends, for long term. And really what you're doing is that's an intergenerational thing, because then your child is gonna grow up, they're gonna inherit that practice from you. And then your future grandchildren and great grandchildren are going to benefit from the fact that you were willing to struggle, willing to make some mistakes, willing to get some things wrong, and it's going to become like a tradition. And and a lot of, and another thing about making mistakes is the formulas and the algorithms that we use all the time. It came from a result of people making mistakes. It's like science. Like, you never hear about like all the 50,000 experiments that didn't go right. You hear about the cure for when they find penicillin. You hear about that, but not the 50,000 experiments that didn't go right. So math is like a similar thing. We gotta get the problems wrong so we can learn how not to do it, you know. So yeah, it's a marathon, not a sprint. Give yourself grace, give your children grace. Don't yell at your kids, because they're gonna shut down, cognitively anyway. So it's like it's pointless, you know. Plus, I think a large part of that is giving ourselves grace, because I know for me, a lot of times when I was yelling at my children, I didn't know how to articulate it at first, but I was disappointed in myself, thinking that I wasn't as good of a teacher as I thought I was, because I'm like, damn, my own son don't get this. I can't teach this to my own son, right? So, but it might have been the first time I ever tried. But I've been kind of indoctrinated into that whole perfection thing, from when I was a child, in school. So that's something that I've been working through over the years, getting away from perfectionism, So as parents, I think y'all gotta give yourselves grace and just be willing to just be like, so it's okay if this method, this attempt to teach them this or help them with the homework, it doesn't go as planned, and we're gonna try something else. So we're gonna come back to it tomorrow, because it's a long school year, and your children gonna be in school for a while.
Yeah. You guys said a mouthful. I'm reminded of a keynote for Deborah Pert. I hope I got her name correct. But she said we have to stop making math optional. She
Mm.
said, you never really hear people say, I'm not a reading person. But you'll hear people all the time say, I'm not a math person. People like, girl, me either. And it's accepted for you to be that way. And it's something that you said that kind of triggered that. I just want us to think about the fact that it should not be optional for us to be successful in math. It's not optional. It doesn't take a certain type of person. Like, I think all of us can be successful in math. We started tonight's session talking about, I can just tell you something and you should be able to get it. And I want you guys to think about why that's a myth. If somebody has ever told you something and you had to say, I need to see it, because you didn't understand what they said to you just through words alone, I want you to remember that every time that you're working with your child and think about that you may need to present it to them in a different way. Just because they did not get it when you said it to them doesn't mean they're not able to get it. So again, as Dana said, productive struggle is key. As Akil said, not only for the kid, but also for the parent as well. So we are going to have to be vulnerable. We're going to have to be transparent, and we're going to have to learn together. Like, it just is what it is. If you want our kids to be successful, we're going to have to be willing to make mistakes together so that we ultimately all can grow. Thank you guys so much for joining us tonight. I love it when we can get into all this math, because all of us have the potential to be young gurus and bud and bear fruit. Until next time, peace.
Deuces.
Peace.